If you have seen my previous videos on this Chinese PMG, you see that I tried to run it at high RPM, but unfortunately it was not able to handle the high voltages that were coming out of it because it had very thin winding, and the insulation on the winding could not handle the voltages, and it kept shorting itself. And I tried to rewind the motor with thicker wires, but then I got into other problems with the magnets configuration because it was a three-phase, and I was trying to make it into a single phase. So I had a lot of problems with that, and I decided this was not the way to go. So I decided that I was going to take this single phase motor and modify its rotor with magnets to turn it into a single phase PMG. So in this video, I'll be taking you through the process or the modifications that I had to do to. It's rated for 1450 revolutions per minute. So that is usually half of what it usually is. So the mains is at 50 hertz, but this is at 25 hertz. So I think this means that the rotor spins at half the main supply frequency. So the first thing I'm going to do is to get the rotor out and measure the size, the circumference of the rotor to know how I'm going to place the magnets on the rotor. So the first thing that I've already done is to remove the fan. I'll be putting this back, but I'll be doing some modification so that the fan also cools the insides, or it cools the magnets on the rotor as well, and not just the exterior, because now we don't want the rotor to overheat because the magnets do not want to overheat. You don't want to heat neodymium magnets above 80 degrees. For neodymium magnets, the cooler you can run them, the better. So I plan to actually run them like very cold. I don't want to exceed 20 degrees C even at the highest load. So I've removed the rotor, and if you can take a look at the windings, you can see that they're using the same thickness for the winding, but what they've done is the starter winding is using two of the winding wires in parallel, and the runner winding is using three of them. Also, the starter winding is the one on the interior, and then the runner winding is in the exterior. So that means that the starter winding is going to be closer to the magnets. I'm not sure whether that's going to affect the power output. And by this I mean it's possible that we could have a mismatch between the voltage for the starter and the rotor windings once we get the magnets in place. So the other thing worth mentioning is, as you saw, the motor is rated for 1450 RPM, which is half the frequency for the main supply. So that means that we have 4 poles in the windings, and that way the windings are going to induce a magnetic field on the rotor that is spinning at half the mains frequency. So that is what is going to inform my magnet placement. So which means I'm going to have 4 poles on the rotor. That is a north followed by a south, followed by a north, followed by a south. You're going to see that later when I'm attaching the magnets. So that's all you need to take into account to decide like how many poles you're going to have for your rotor in the magnets. So if the RPM rating for the motor is same as the means, then it means you just need 2 poles. So half of the rotor is going to be north and half of it is going to be south. But that means then you'll have to spin it at the same RPM for you to get the output voltage to be the same frequency as the main supply. So once I got the rotor out, the next thing that I needed to do was to measure the circumference of the rotor, because this was going to determine the placement for the magnets and also what kind of modifications I will need to do to the rotor so that I could fit in the magnets correctly. So that's what I did here. I got a piece of paper and I folded it across and marked where it intersected, and I got the circumference for the rotor. So after that, I went to Aliexpress and searched for arc magnets. There are a lot of offers, but I could not find a magnet that was the same radius as the rotor. So I had to look for the one that was the closest match, and then my plan was to get that one, and then I would grind it to conform to the rotor, as you'll see later in the video. As I waited for the magnets to ship, I got some lathe work done on the rotor. I decided to go with 3 grooves with walls beside them, between them. Those walls are very important because they help to align the magnets and also offers mechanical support. It's better than just placing them on a plain rotor. Also, the depth is also important, that you get the correct depth for the grooves, so that you're not going to have magnets protruding or getting far away from the stator. You want to maintain the same tolerances that the rotor had, so that you can get the maximum power output. So once I got the magnets, I ground them like I had said, so that they would fit the thickness that I had assigned for each of the magnets. You just need to be very gentle with the grinding, and make sure that you have some water around. The last thing I wanted to do was to get the magnets hot or even warm. I wanted them to maintain a good temperature. So I was grinding as I would dip them into some cold water. So the good thing is the grinding wheel is not magnetic, so it does not attract the magnet. You need to be careful not to release the magnet and ruin it. After grading the magnets, the next step is to attach them to the rotor. As you can see, I've already attached 2 rows of the magnets. Now I'm on the last one. So the thing is, you need to keep them. So the arc magnets come in pairs. If you order like 8, you get 4 with north on the outer radius and 4 with south on the outer radius. So they are balanced, which is what we need. I also got the glue. So this was a special glue that was actually advertised as serving this very specific purpose for attaching magnets to rotors for motors. On Aliexpress, I came together with the magnets. So I'm going to leave a link for both the magnets and this glue in the description of this video. So the next thing is you need to make sure that you maintain the correct polarity for the magnets. So as I said, I was doing 4 norths, like 4 magnets facing north on the outside, and 4 magnets, the next 4 magnets facing south on the outside. And you have to make sure that all the magnets for the row have the same polarity. And you can very easily test for this using the already existing magnets. You'll get the point, the polarity that you need to place. So after placing all the magnets on the rotor and giving the glue at least 24 hours for it to cure completely, so that the magnets are strongly attached to the rotor. The next step was to insert the rotor into the motor, now with the magnets. So the pull on this was very strong, and I could not resist it from just jumping right into the motor. But yeah, that was a nice fit. And then after replacing the caps, I give it a spin to make sure that the rotor was spinning freely. So by this time I had already drilled some holes into the caps for cooling purposes, as you'll see later during the fan assembly. So the next thing that I was going to take into account was the active cooling. So the motor comes with this fan, but this one draws the air from the rear of this cover. So this is a centrifugal pump for air. So as it spins, it pushes air out, and then more air comes in from the back. But what I'm going to do is I've drilled these holes through this casing, and similarly in the front. So what is going to happen is now I'm going to force this fan to draw air from the front and then push it out from the top. So the way I'm going to do that is I'm going to cover this rear side so that air cannot come in through here. So when this fan spins, as the air exits from the top, the only other place that the air can come in from is the inside the motor. So that means that the air is going to come in from the front, pass through the magnets, and between the magnets and the stator, that small space. So as it passes it over the magnet, it's going to cool them, and then it's going to come out, and then it's still going to cool the exterior just like it was doing previously on the external casing. But most of the cooling is going to be happening internally. Later, I'm going to design a mechanism to filter the air that is coming in because we don't want dust accumulating inside the PMG. But that's for later. That is not going to prevent the PMG from working like it is right now. So I've got this plastic cup that I got that seems to fit nicely into this hole here, into the cover. So I'm simply going to apply some silicone to the cup, a copious amount, just to make sure that I get a nice seal so that the air will not come from the rear, and that it will only come from inside the PMG. So that is all I need to do. And then I place it on the cover. So I'll leave that in that position for it to set and cure. So that'll be about 24 hours, but should be few. So I think now we can do some quick measurements, initial measurements, before I do the setup to actually test the power output. So first of all, for the centrifugal switch, I've connected the two wires together. So that means the starter winding now should have a complete circuit. So these are the rotor winding terminals, and these are the starter winding terminals. They are 180 degrees out of phase. So first of all, let's do a rotation resistance test. So on the rotor winding, yes, there's a lot of resistance, but of course, as you can see, there's a section where it moves easily when the magnets are not like fully aligned with the winding. And then for the starter winding as well, similar thing. It should be, that's what we expect. So when I short all of them, I should expect there to be continuous, yes, there's continuous resistance to the rotation. It's actually very strong. So we're expecting to have some good power output out of this. So the next thing is, let's try to do a quick voltage reading, output voltage. hard spin output voltage reading. So this is now the rotor winding, and yeah, see we have 1 volt. We give it a good spin. Yeah, 12 volts, 14 volts. So I think the best way to know the voltage output is to actually connect this to an engine. I'll do that in the next video and see the output. I would expect the same level of output voltage for the starter winding because they have the same number of windings. Yeah, see 12 volt, 14 volts. Yep. So the next thing we can test is the winding resistance. So this has very thick windings, so I expect it to have like minimal, very low resistance. So we have the probe resistance is 9.3 ohms. So and then the rotor winding has it's pretty much around the same values. It has very minimal resistance. Even for the at least the starter winding has a little bit more, like 0.1 ohm more. Or maybe the sensitivity of this meter is not sufficient to accurately measure the resistance, but it's very low, which means that we can draw very high currents from this PMG, unlike the Chinese one. So yeah, I'm very eager to set this up and see like what kind of power we get out of this. So the aim is to try to spin it to generate 50 hertz, and then I'll see what voltage I have, because that means then I'll be able to use the PMG directly as a supply to all the appliances, just like the main supply, because the main supply here is 240 volts and 50 hertz. So it's been 24 hours now, and the silicon have cured fully. Now the lid is nicely fitted, so now I can put back the fan. So the two wires for the centrifugal switch, I just connected them together and then insulated them properly and tied them here because I don't want them to interfere with the fan. So the wires for the capacitors, I just leave those hanging loose. Later on, I might do some experiments to see whether it'll be possible to actually shift the phase for the starter winding to be in phase with the rotor winding, to see whether I could actually combine both the outputs into one. But that's for later. So the way the fan is going to work is I'm going to fit it in this way. And the good thing about fitting it in this is the same way that it was fitted previously, so nothing changes. There are no fins on the front side, which means we won't have any air. First of all, it won't touch the body, so that's still safe. And then we won't have any centrifugal forces acting on the air on this side. So it means the forces will only be acting on the air from this side. So that means when the air comes in, it won't be diverted immediately outwards, but it will have to come in through these holes to the rear side, and then it will be pushed out. And that's going to provide a more smoother flow of the air, because we don't want a lot of turbulence when the fan is blowing. So I'm just going to push in the fan. So it has a groove, but I think it should be able to push it in easily. Yeah. So I think that's the farthest that I back there, because you don't. So from there, the only thing left now is to put in the rear or the cover, the fan cover. And so I have the PMG wired up to the flywheel and the petrol engine. and then I got the LPG, that's the source of the energy. So what I want to do is I just want to do a demonstration of the typical output that I'm getting from the PMG. Regarding the readings, by the time I get to 50 hertz output, I'm getting around 210 volts. That is closely in correspondence to what we have with the main supply here. I'll be doing a more thorough testing of the output capability of the PMG in a separate video. I just want to show you like the typical output that I'm getting right now. So I created this one for starting the engine. So I get the LPG running, a little bit of it. So as you've seen, welding, grinding, that's child play for this PMG. So yeah, I think this is a great success, and I'm very eager to see how much power I'll eventually get out of this from my micro hydro project. So if you're not subscribed, please subscribe, because there'll be more videos like this coming along, and also be uploading videos for the water wheel as well.